Regarding the 40 amp breaker conduit requirement, according to the National Electrical Code, a 40 amp circuit must be installed in conduit if it is not part of a service panel. This is because the high current capacity of the circuit requires additional protection against shorts and grounds. In this case, the 40 amp breaker is likely part of a service panel since it is supplying power to the range. Therefore, conduit may not be required. However, it is always recommended to consult with a local electrical inspector for definitive guidance. Regarding the 210-3 wires current capacity, 210-3 wires have a combined current capacity of 40 amps since each 10 American wire gauge wire has 10 amps per conductor times 4 conductors. This is sufficient for most ranges, which typically draw around 30 amps. Concerning the outside parameters, the NEC does not specify any specific requirements for the outside parameters of a 10-3 wire, as long as it is properly installed and protected from damage. However, it is important to ensure that the wires are firstly installed in a suitable enclosure or conduit, secondly, properly terminated and connected, and thirdly, protected from environmental factors such as moisture and heat. Additional considerations must be made. The lack of a ground wire is a potential safety hazard. It is highly recommended to install a ground wire for the range. Concerning an electrical inspection, it is always advisable to have a qualified electrician inspect the electrical system of an older home to ensure it meets current safety standards. It is recommended to consult with a local electrical inspector to determine the specific requirements for your situation. If a ground wire is not present, install one for added safety. Ensure that all wires are properly installed and protected. Have the electrical system inspected by a qualified electrician for peace of mind. Now let's delve deeper into each of these points, expanding on the technical aspects and safety considerations. Firstly, regarding the 40 amp breaker and the conduit requirement, the NEC provides specific guidelines for overcurrent protection devices like circuit breakers and their installation. The primary reason for requiring conduit in certain scenarios is to provide a robust physical barrier against potential damage to the conductors. This damage could result from mechanical stress, abrasion, or environmental factors such as moisture or corrosive substances. Conduit also helps to contain any arc flash or fire that might occur due to a fault within the circuit. If the 40 amp breaker is indeed part of the service panel, it's likely that the panel itself provides adequate protection, thus potentially negating the need for additional conduit. However, it is crucial to verify this with a local electrical inspector, as interpretations and local amendments to the NEC can vary. The inspector will consider factors such as the panel's construction, its location, and the overall wiring methods employed in the house. Secondly, let's examine the current capacity of the 210-3 wires. While the combined capacity may seem sufficient for a typical range, it's essential to understand the limitations and potential risks. Each 10 American wire gauge copper conductor is generally rated for around 30 amps, but this rating can be derated based on several factors, including the ambient temperature, the number of conductors bundled together, and the type of insulation used. In this scenario, with 4 current-carrying conductors, 2 hots and 2 neutrals bundled together in a single cable, derating may be necessary. The NEC provides tables such as Table 310.15 B3a that specify the allowable ampacity derating factors for multiple conductors in a raceway or cable. Furthermore, the age and condition of the wires can significantly impact their current carrying capacity. Over time, the insulation can degrade, becoming brittle and less effective at preventing shorts and grounds. Therefore, a thorough inspection of the wires is crucial to assess their condition and ensure they can safely handle the intended load. Thirdly, concerning the outside parameters of the 10-3 wire installation, the NEC emphasizes the importance of protecting conductors from physical damage and environmental factors. If the wires are run outdoors, they must be installed in a suitable raceway, such as conduit or electrical metallic tubing, or be rated for direct burial if buried underground. The raceway or direct burial cable must be installed at the correct depth, as specified by the NEC, to prevent damage from digging or other activities. Additionally, the wires must be protected from exposure to sunlight, which can degrade the insulation over time. UV-resistant cables or conduits should be used in areas exposed to direct sunlight. Terminations and connections are also critical aspects of the installation. All connections must be made in approved junction boxes or enclosures and must be properly tightened to ensure a secure and reliable connection. Loose connections can cause arcing, which can lead to overheating and potentially a fire. Furthermore, the junction boxes or enclosures must be suitable for the environment in which they are installed. For example, if the junction box is located in a damp or wet location, it must be rated for that environment to prevent moisture from entering and corroding the connections. Grounding is another critical safety consideration. The absence of a ground wire in the original wiring is a significant safety hazard. A ground wire provides a low impedance path for fault current to flow back to the source, allowing the overcurrent protection device, such as the circuit breaker, to trip and de-energize the circuit in the event of a ground fault. Without a ground wire, a ground fault can cause the metal parts of the appliance, such as the range, to become energized, pose a shock hazard to anyone who touches it. Retrofitting a ground wire can be challenging in older homes, but it is highly recommended. There are several methods for doing so, including running a separate ground wire back to the service panel or using a ground fault circuit interrupter GFCI breaker to protect the circuit. A GFCI breaker detects even small amounts of current leakage to ground and trips the circuit, preventing a shock. However, a GFCI breaker does not provide the same level of protection as a properly installed ground wire, so it should only be used as a last resort. Finally, a comprehensive electrical inspection by a qualified electrician is essential for ensuring the safety and reliability of the electrical system in an older home. An electrician can identify potential hazards such as deteriorated wiring, overloaded circuits, and improper grounding, and recommend corrective actions. The electrician will also be familiar with local codes and regulations and can ensure that the electrical system meets current safety standards. In addition to the points mentioned above, there are several other technical aspects to consider when evaluating the range wiring in older homes. Firstly, the voltage drop in the wiring should be calculated to ensure that the range receives adequate voltage under load. Excessive voltage drop can cause the range to operate inefficiently and can even damage its components. The NEC provides guidelines for calculating voltage drop and specifies the maximum allowable voltage drop for branch circuits. Secondly, the type of wiring used in the original installation should be identified. Older homes may have wiring that is no longer approved for use, such as knob and tube wiring. If this type of wiring is present, it should be replaced with modern wiring methods. Thirdly, the overcurrent protection devices should be properly sized to protect the wiring from overload. Oversized circuit breakers can allow excessive current to flow through the wiring, which can cause it to overheat and potentially start a fire. The NEC provides tables that specify the correct size of overcurrent protection devices for different sizes of conductors. Fourthly, the grounding system should be thoroughly inspected to ensure that it is properly installed and functioning. A properly installed grounding system is essential for preventing electrical shock hazards. The grounding system should be tested to verify that it has a low impedance path to ground. Fifthly, the presence of any aluminum wiring should be noted. Aluminum wiring was used in some homes in the 1960s and 1970s, and it can pose a fire hazard if it is not properly installed and maintained. Aluminum wiring expands and contracts more than copper wiring, which can cause connections to loosen over time. Loose connections can cause arcing, which can lead to overheating and potentially a fire. If aluminum wiring is present, it should be inspected by a qualified electrician and repaired or replaced as necessary. Sixthly, the overall condition of the electrical system should be assessed. Older electrical systems may have deteriorated components such as outlets, switches, and light fixtures. These components should be replaced if they are damaged or worn out. Seventhly, the presence of any ungrounded outlets should be noted. Ungrounded outlets can pose a shock hazard, especially in kitchens and bathrooms. and grounded outlets should be replaced with grounded outlets are protected by GFCI-S. Eighthly, the location of the service panel should be reviewed. The service panel should be readily accessible and should have adequate space for future expansion. If the service panel is located in a damp or wet location, it should be relocated to a drier location. Ninthly, the labeling of the circuits should be checked. All circuits should be clearly labeled to indicate what they serve. This will make it easier to troubleshoot electrical problems in the future. Tenthly, the presence of any open junction boxes should be noted. Open junction boxes can pose a shock hazard and should be closed with approved covers. 11thly, the condition of the electrical meter should be inspected. The electrical meter should be in good condition and should be properly sealed. 12thly, the presence of any temporary wiring should be noted. Temporary wiring is often used during construction or remodeling, but it should be removed as soon as it is no longer needed. Temporary wiring can pose a fire hazard and should not be used as a permanent wiring method. 13thly, the presence of any extension cords should be noted. Extension cords should only be used for temporary applications and should not be used as a substitute for permanent wiring. Extension cords can be easily damaged and can pose a fire hazard if they are overloaded. 14thly, the presence of any power strip should be noted. Power strips should only be used to power low wattage devices, such as computers and peripherals. Power strips should not be used to power high wattage devices, such as space heaters or air conditioners. Power strips can be easily overloaded and can pose a fire hazard if they are not used properly. 15thly, the presence of any surge protectors should be noted. Surge protectors can help to protect electronic devices from damage caused by power surges. Surge protectors should be installed on all circuits that power sensitive electronic equipment. 16thly, the presence of any smoke detectors should be noted. Smoke detectors are essential for protecting lives and property from fire. Smoke detectors should be installed on every level of a home and should be tested regularly. 17thly, the presence of any carbon monoxide detectors should be noted. Carbon monoxide detectors are essential for protecting lives from carbon monoxide poisoning. Carbon monoxide detectors should be installed near sleeping areas and should be tested regularly. 18thly, the presence of any fire extinguishers should be noted. Fire extinguishers can be used to put out small fires before they spread. Fire extinguishers should be installed in kitchens and other areas where there is a risk of fire. 19thly, the presence of any emergency lighting should be noted. Emergency lighting can help people to evacuate the home safely in the event of a power outage. Emergency lighting should be installed in hallways and stairwells. 20thly, the presence of any GFCI outlets should be noted. GFCI outlets are designed to protect people from electrical shock. GFCI outlets should be installed in bathrooms, kitchens, and other areas where there is a risk of water exposure. 21stly, any exposed electrical wiring should be professionally covered immediately. 22ndly, all electrical outlets should be tamper resistant, especially if there are children in the household. 23rdly, avoid overloading circuits by plugging too many devices into one outlet. 24thly, regularly check for frayed or damaged electrical cords. 25thly, never run electrical cords under rugs or carpets, as this can cause them to overheat. 26thly, use light bulbs with the correct wattage for the fixture to prevent overheating. 27thly, consider installing a whole house surge protector to protect your home from power surges. These devices are installed at the electrical panel and can provide comprehensive protection. 28thly, be cautious when using electricity near water. Never touch electrical devices with wet hands. 29thly, turn off lights and appliances when not in use to save energy and reduce the risk of electrical fires. 30thly, be aware of the signs of an electrical problem, such as flickering lights, burning smells, or warm outlets. If you notice any of these signs, call a qualified electrician immediately. Consulting with a local electrical inspector to determine the specific requirements for the particular situation, and if a ground wire is not present, install one for added safety. Ensure that all wires are properly installed and protected, and have the electrical system inspected by a qualified electrician. For peace of mind are all recommendations that should be followed to ensure safety standards are met.